Hello, Math 7 students. This is Open Up Resources, Unit 3, Lesson 10, Distinguishing Circumference and Area. This is Part 2. You might remember in our last lesson, we finished up with a card sort, where we had these 8 cards and we were sorting them into stacks of which ones dealt with area and which ones dealt with circumference. So we're going to pick up right there, knowing which ones have already been put in the circumference pile, which ones have already been put in the area pile, and we no longer have the cards in front of us, but we should have labeled it within our own packet which ones were area and circumference. So picking up there, we've now done the card sort. I'm going to assign you a card to look at more closely. I'm going to actually assign 2. And it's asking for what additional information would we need in order to answer the question. And estimate the measurements for the circle on your card. Then we'll use the estimates to calculate the answers to the question. So let's get started. The ones that I want you to actually look at and pay more attention to are question 1 and question 2. Those are the ones to focus on. So question 1 says how much fabric is needed for a round tablecloth. We already decided that that's area. So knowing that this is an area problem, let's think about the information we need in order to calculate area. In other words, what's the formula for area of a circle? The area of a circle is equal to the radius squared, which is then multiplied by pi. So if I need to be able to answer this question, the information that I'm missing is the radius. I need to figure out what the radius is. So now is where you get to create an estimate for the radius of this circle. Think about a table. Think about a round table. Think about how many people should maybe sit around that. And think about what kind of a measurement is going to be the best one for the radius. Should we measure in feet? Should we measure in inches? Do you have a good guess? All right, so if I am looking at a whole entire circular table, looking at just the radius, if I want a couple of people, maybe 8 people, to be able to fit around this, then I think it's pretty clear that just 2 feet is not going to be long enough. 2 feet is only going to create a table with a 4-foot diameter. That's about how big the table that you're sitting at is. We're not going to be able to fit 8 people around a table that's that size. So with that in mind, what is a better measurement that I could come up with, a better estimate for my radius? Pause the video now to give yourself enough time to come up with a good estimate, and then we'll go over it once you've come up with your estimate. Pause the video now. All right, your estimate is ultimately up to you, but I think anything from maybe about a 3 to 5 foot radius, maybe even a 6 foot radius would be appropriate here. Let's go in the middle. Let's just say the radius is 5 feet. Just so that we can all be consistent, let's go ahead and pretend that our radius is 5 feet for this table. Now it's time to calculate the area. The area is equal to the radius squared multiplied by pi. So 5 squared multiplied by pi, I simply plug that into my calculator and I get an area of 78.5398, and there's multiple other decimals here, and our unit of measurement is going to be feet squared. Now, keep in mind, all we have done here, if we're kind of looking at this picture here, all we've done is figured out the area of the surface of the table. So we need that much fabric. Now, you've also mentioned in class that the tablecloth is going to hang down the sides. So we're going to need extra fabric in order to be able to hang down the sides. So in this case, maybe rounding up is going to be more appropriate since we want extra fabric. So if you want to change that, rounding up, you can give yourself a bit of extra. We can go all the way up to 85 feet squared in order to make a tablecloth. Okay, question 2. Again, we know that this is a circumference problem. We're going around a Ferris wheel. We want to know how fast are we going to go when we go around the Ferris wheel. So what extra information do we need? Again, the key thing to remember is since this is a circumference problem, we need to know the relationship between circumference and the other parts of the circle. You can write it in terms of the radius, because the radius doubled, then multiplied by pi, is equal to the circumference. If you want to, you can also do it in terms of the diameter. The circumference is equal to the diameter multiplied by pi. You can make whatever choice you want to here, but here's what I'm seeing. I'm seeing this pattern throughout all of these problems. the radius is part of the area, and the radius, if I choose the formula, is also going to be part of the circumference. So if I just want to be consistent all the way through, I can always decide, you know what, let's choose the radius for this problem. We know what to do if we have a radius, we know what to do if we have a diameter, so you can make the choice on what you want to do there. So again, we need to come up with an estimate. You've been on different Ferris wheels before. If you've been to the state fair or the county fair, it's probably a much smaller Ferris wheel than if you go to Lagoon and ride the skyscraper Ferris wheel. So you can decide what are some appropriate estimates and how should we measure it. Is it appropriate to measure a Ferris wheel radius or diameter in inches? Probably not. Maybe we should go bigger, measure in feet or in yards or in meters. So again, pause the recording as you come up with an appropriate estimate for the radius or diameter of a Ferris wheel. All right. Now there's no real right or wrong answer here. These are just estimates. But I would say a radius of anywhere between 30 feet to maybe 80 feet is appropriate. Just depends on exactly how big it is going to be. Let's choose another one. Let's choose one pretty close to the middle. Let's say a 60-foot radius. So if our radius is 60 feet, what are we going to do with that in order to find the circumference? So again, my radius is 60 feet. I'm going to use this formula for circumference using radius. That's going to be 60 multiplied by 2 multiplied by pi. That'll give me the circumference of the Ferris wheel, how far a rider is going to travel when they go all the way around that Ferris wheel. And the circumference, when I plug that into my calculator, is 376.99. And yes, there's some other decimals. Our units of measure are, of course, going to be feet. Now, I want you to think about this question. This one's a tough one because the question is asking not just how far we're going, if we're going around the Ferris wheel, but how fast. So there's an extra piece of information that we would need that is not really something that I'm going to expect you to do regularly. But if I want to know the fastness or the speed, we measure that in distance per time. So we have already found the distance that we would be traveling. The other element that we would need that is not part of this problem, we would have to estimate how long does it take to go around that circle, around that Ferris wheel. And then after we estimate that, then we could come up with the speed or how fast we're going. All right, that's it for that portion. Here's what I want to do now. Using some of these same examples in these same situations, we have some students who have tried solving some problems, and we want to analyze and see if we agree with them or not. So here's two students' answers for the merry-go-round one. That is not one that I had you do, but let's take a look and see what they each have to say. The question is, how many feet are traveled by a person riding once around the merry-go-round? So imagine a merry-go-round. You've seen them before. How big are they? What kind of measurements would we use? And Claire says the radius of the merry-go-round is about 4 feet. So the distance around the edge is about 8 pi feet. Andre says the diameter of the merry-go-round is about 4 feet. So the distance around the edge is about 4 pi feet. Now, you have to read that closely. What's the difference in their claims? If you notice, Claire is saying that the radius of the merry-go-round is 4 feet, and Andre is saying that the diameter of the merry-go-round is 4 feet. So it's time for you to be the judge. Looking at the merry-go-round, looking at the student that you can see here on the merry-go-round, what do you think is more appropriate? A radius being 4 feet or the whole diameter being 4 feet? Again, 4 feet is about how wide your table is approximately. So use that as a guide. We're going to pause the recording as you discuss in class or give yourself some extra think time. Who do you think is making the better claim? Pause the recording now. All right, what did you decide? I think that the more appropriate estimate is just the radius being 4 feet. Just going from the center to the edge, that being 4 feet, that would make the whole entire diameter be 8 feet because the radius doubled is the diameter. And I think that that is a more appropriate measurement. So I agree with Claire as far as the measurement goes, the estimate of the measurement. Let's see her calculations. If we have a radius, Then, in order to find that circumference, we would need to multiply the radius by 2 and then multiply it by pi. Now, we haven't done this for a little while, but you're going to notice Claire did not type everything into her calculator. Claire just calculated this amount. 4 times 2 is 8, so the whole circumference would be 8 pi. Remember, that's what we call keeping it in terms of pi. So this answer is still in terms of pi, 8 pi. It looks like Claire's calculation has been done correctly. Let's take a look at Andre's calculation. Now, we don't agree with his measurement. We think that his measurement was probably a little bit too small, but let's take a look at his work. If we have a diameter, then to find the circumference, I simply multiply that diameter by pi. His diameter estimate is 4 feet, and he has taken that 4 diameter and multiplied it by pi. Again, he didn't plug it into his calculator. He kept it in terms of pi. And so again, it looks like he did his calculations correctly. So who do we ultimately agree with in the end? I hope that we agree with Claire. Claire has a better estimate for the measurement. All right, let's look at some more situations. Let's say I'm putting frosting on a cookie. We saw one of those as one of our cards. If I'm putting frosting on the cookie, where am I spreading that frosting? Again, we've already talked about this in our last lesson. We're not putting the frosting just around the edges, right? We're putting frosting across the whole entire cookie, which means I'm filling up the whole area with frosting. So if the radius of the cookie is 3 centimeters, imagine 3 centimeters. Just a little bit over an inch, so it's a pretty small cookie. We're not talking crumble-sized cookies, we're just talking the small ones that you might make at home. So 3 centimeters, and if that radius is 3 centimeters, how much room is there to spread frosting on the cookie? If you remember from our sort, we know that this is an area problem. So the area is found by taking the radius and squaring it and multiplying it by pi. Let's do that then. The radius is 3 centimeters. Multiplied by pi. That's going to be our area. So if we want to be like Claire and Andre were in the last problem, we can keep this in terms of pi, and that means I'll calculate the 3 squared. 3 multiplied by itself is 9. Or if you want to calculate that all the way out, 9 pi is equal to 28.27. There's some extra decimals, but that's good enough for now. And again, how much room is that? We're not just measuring centimeters anymore, we're measuring centimeters square. All right, well, what if the diameter is 3 centimeters? So again, I'm not just talking about just from center to edge, now I'm talking about the whole entire diameter is 3 centimeters. Is that going to be a bigger or a smaller cookie now? That's going to be like, you know when you get those little Chips Ahoy cookies that are in the little bag? They're a little bite-sized. These are those bite-sized cookies. Imagine what 3 centimeters is for a diameter. So what am I going to do when I'm given a diameter and the area uses the radius? We still need to find the area, but now the information I'm given is not quite what I need. So we're going to manipulate it. If the diameter is equal to 3, then I know that a radius is going to be half of that. So if the diameter is 3, then the radius is half of that, or 1.5. Now we're ready. Again, we can't just use that information that was given. We had to manipulate it, but the radius is 1.5, and we're going to square that. Multiply that by pi. 1.5 squared. Using your calculators, you should be punching this in with me just the same as I'm doing. When I punch that into my calculator, I get the area is equal to 7.0685 centimeters squared. You can see just how much different that is. A lot less space when we shrink the size of that cookie. Okay, the next one, we also had a unicycle problem in our card sort. Looking at the unicycle, how far is that unicycle going to move when the wheel makes 5 full rotations? Let's review. This is a circumference problem if we go back to our card sort, but let's make sure we understand why. The unicycle, the tire that touches the ground is the outside edge. the spokes don't touch the ground, it's only that outside edge. So that's what makes this a circumference problem. As the wheel spins, a different part of it is touching the ground. So eventually all of the different parts of the ground will touch the ground, and it will have traveled, not downhill like that, it will have traveled, I don't know, about that distance when it's all straightened out. So that's why this is a circumference problem. And again, we can write circumference in terms of diameter or radius. We've been focusing a lot on radius, so let's go ahead and do it in terms of diameter. So to find the circumference, it's the diameter multiplied by pi. Now here's a problem. They did not give us an estimate or any actual measurement about how big this unicycle wheel is. So again, take your best guess. Look at how tall the person is. Look at how big that unicycle is. How big is the wheel? I'm going to change up the measurements here, and I'm going to say, instead of using our imperial measurements, let's go ahead and use the metric system. Let's estimate the diameter to be about 1/2 meter. Again, the diameter going all the way through, that's going to be about 1/2 meter. So we need to find the circumference. How far is it going to travel when it goes around? 0.5 of a meter times pi, that is equal to the circumference. Go ahead and plug that into your calculators. 0.5 times pi is equal to 1.5707. I think that's probably good enough. We can go 9. And again, the units of measurement, we switched it up and now we're using meters, so it's still going to be meters. But again, I haven't quite answered the question yet. How far does a unicycle move when the wheel makes 5 full rotations? That means this is how much it's gone around going 1 time. But we need to do that how many more times? 5 more times. So I'm going to take that circumference and I am now going to multiply it by 5 so that I can get how far it has traveled. In our calculators, we're going to multiply that by 5, and that means that our distance, the distance that we have traveled when the unicycle has gone around 5 full times, is about 7.8 meters. All right, that's it. We've made it to the end of the lesson. It's time to summarize. Sometimes we need to find the circumference of a circle, and sometimes we need to find the area. That's all there is to it. We've been trying to mix it up a little bit in the last couple of lessons to get used to it. Here are some examples that are related to the circumference of a circle, the length of a circular path. Again, if I'm walking on a circular path, that would be the circumference because I'm staying on the outside. The distance a wheel will travel after 1 complete rotation, just like our unicycle. That's an example of circumference. And the length of a piece of rope that's been coiled into a circle. Again, those are all things that are happening on the outside of a circle, so that's going to be the circumference. And here are some examples of quantities that are related to the area of a circle. The amount of land that is cultivated on a circular field. So again, we still have our circular field, but the land that's cultivated, I'm not just going to stay around here on the outside edges. I'm going to cultivate all of the land on the inside. That makes it area. The amount of frosting needed to cover the top of a round cake. Notice we said the top of a round cake. I am not a good 3D artist here, but if I've got this round cake, yes, ultimately I'm going to want to cover the outside edge with frosting, but I also definitely want to cover the top with frosting, and it's the top part that we're talking about, so that is going to be area. The number of tiles that we would need to cover a round table. So again, not a great 3D artist here, but if I've got a round table, it's got some legs going on back there, and I want to cover that whole entire top with squares, I'm not just covering the edge, I'm covering the whole entire thing, so that turns that into an area problem. In both cases, the radius or the diameter is all that we need. And the reason it's the only thing that we need is because we remember that it takes 2 radius to make a diameter. So if I want to use radius, but I'm given a diameter, I can do that. I just have to manipulate that information. Some other things to remember, the circumference of a circle, if I give you the radius, is 2 multiplied by pi multiplied by r. We've typically written it in a different order. We've normally said the radius, which is then multiplied by 2, which is multiplied by pi, but they mean the same thing. and the area of that circle is pi r squared. Again, we've normally written it differently. We've normally written it r squared, then multiplied by pi, but they mean the same thing. And as you saw in this, we can measure the diameter, the radius, the circumference, the area. We can measure all of them in all sorts of different units. But the key thing to remember is when I'm dealing with circumference, the units are linear units, meaning centimeters, inches, kilometers, meaning I could just take a ruler or a measuring tape and stretch it across. Whereas the area itself is measured in square units, such as centimeters squared, inches squared, kilometers squared, where instead of just stretching out a measuring tape, I need to cut out a bunch of squares and figure out how many squares it's going to take to fill that in. So that's a key thing there on the units. Let's finish up with our cool down. A circular lawn has a row of bricks around the edge. The diameter of the lawn is about 40 feet. You've got an image here to help you out. Which of these estimates, A, B, C, or D, which is the best estimate for the amount of grass in the lawn? Again, pay attention to the information that's given. How are we going to use that to answer this question? Is this an area or circumference problem? Pause the recording, give yourself a chance to think about it. Those of you who finish early, go ahead and answer question 2 as well. Pause the recording now. All right, let's go over this. The diameter that it estimated is about 40 feet. This, since I'm talking about the lawn, the amount of grass, that's the inside, and that's an area problem. Since area is in terms of the radius squared multiplied by pi, that means I need to cut this diameter in half. And cutting the diameter in half gives me a radius, and that means that radius is 20 feet. So plugging that in, I have 20 feet squared, which is then multiplied by pi. I plug that into my calculator, and it tells me that it is about 1,256.637 feet squared. So which one of those is the closest? Ooh, I have two of them, 1,250 feet and 1,250 square feet. Again, when we're talking about area, we're talking about how many squares could we fit in there. So it's not just feet, it's going to be feet squared. And number 2. Which of the above options is the best estimate for the total length of the bricks? So we can see these bricks here on the outside, but again, notice where those bricks are. Those bricks are on the outside. That would be a circumference problem. So circumference, I don't need to use the radius. I can use the diameter that it gave me. Again, that's just the diameter multiplied by pi. But what is that diameter? 40 times pi. Plugging that into the calculator, we get about 125.6637. And let's look at our options. I see 125 or something close to it, pretty close to this answer twice, A or B. But again, is it going to be feet or is it going to be square feet? Even though the bricks are this shape, we're talking about how many of them we need to go around the outside. That means I could stretch my tape measure all the way around to measure it. So that's going to be linear feet, 125 feet, so option A. That is it for this lesson. Your homework is the lesson 10 practice problems, and there is a problem that I want to cover really quick. If you take a look at number 2, it says the city of Paris, France is completely contained within an almost circular road that goes around the edge. Here's a map. If you notice, the map is a circle, but that's not what they're talking about. Pay attention to, here's Paris. Can you find that pretty circular road? It's this right here. No, it's not a perfect circle, but we can use it as an estimate. And you're going to see, once I pay attention just to that road, and I can see that we've got this scale where this distance here is 1 mile, I want to use that to try and estimate what is the radius or what is the diameter. But again, as I'm doing that, make sure you understand I'm not going all the way to the edge of the picture of the circle, because a street doesn't go to the edge, and over here it definitely doesn't go to the edge. So we're not going all the way to the edge of the picture. Focus on that mostly circular road that I drew and make your estimate there about what is that radius, and then use that to answer that question. That's really all that I needed to go over. The rest of the homework is pretty self-explanatory. So that's it for today. Thanks for watching. We'll see you next time.